So this is a neat website you can use to automate a lot of the processes that we'll study in this course. A lot of them we're not familiar with yet, but the one that we are familiar with is Gauss-Jordan elimination. And that's what we're going to use to solve this system that we just encountered, the one that had decimal places as the entries. So first thing I got to do is set the matrix dimension. So there's 4 equations and 3 variables, but don't forget there's also a constant column. So we actually have 4 columns and 4 rows. So we'll go to set the matrix, and you just simply enter the values. So for our first equation, the coefficients were 0.25, 0.5. This is just the first row of our augmented matrix, 0, and then 0.2. That's the first equation. And then our second equation, we've got 0.25, 0.5, 0.5, and 0.4 for the constant. And then for the third equation, we had 0.5, 0, 0.5, and 0.4. Oops, not 3, 0.4. And then our last equation, we just had 0, 0, 0, and 0. Now, did we really need to include that equation? No, it's not going to change anything. If you did a 3 by 4 matrix and only entered the first 3 rows, you get the same answer. But anyways, let's just keep going. So now I'm going to go ahead and click solve, and it will give me the answer. So look at that. We've got x1 is 0.4, x2 is 0.2, x3 is 0.4. Notice it's using the letters x. It's using x for the variables. Well, you have to interpret that for your own work, right? So we used k1, k2, and k3 for the variables. So that's what we'll actually assign those values to. And by the way, a neat thing about this is you can always check the work too. If I click show solution, it'll actually show me all the steps. It does Gauss-Jordan elimination a little bit differently than the way we did it in class, but to be honest, I actually like the way it does it. What it does is as it does the row reducing, it turns each of the leading entries into ones as it goes through, and then it clears all the entries above and below. It basically combines the forward and backward phase into one pass. So you can, and feel free to use that method as well. But so just if you're ever using this tool and you're reading the solution, just so you know that it's going to be a little bit different than the Gauss-Jordan elimination method, the way we studied in class, but it still works. Okay, and then you go all the way down to the bottom and it will tell you the same answer that we just got from it.